at least 18 inches below the ceiling. You need to use explosion-proof lights. There again, we want to make sure that there aren't any sparks that could cause, if we had an explosive atmosphere, to go off. You want to consult NFPA 5230 regulations along with your local, state, and federal guidelines as far as setting up a shop to do it. Most shops that are doing repairs right now have been through that, and the one thing to keep in mind is your local fire marshal is the one that has to say over anything concerning regulations as far as what you follow. You need methane detection and additional ventilation to go with it. On the slide I just brought up, it does show part of the detection as far as methane. It also shows additional ventilation that has been put in the roof of this facility where I took the picture. The thing to keep in mind is if methane is detected, you're going to actually have it to where the vent automatically opens and it vents the entire shop, allows the bay doors to come up automatically, so we can move 8 times the amount of normal air through the shop to get rid of the methane. So, and this could happen even if you were not at the shop at the time. If the methane detector went off, your bay doors go up automatically, the fans turn on, and it sucks all the air out of so we don't have a fire. No open flame heaters at all. This came from a shop up north, but we have radiant heaters and it's all entirely enclosed, so we don't have any type of flame that could come through. If you're working down in the south, obviously that probably wouldn't be an issue. You can go out underneath the carport somewhere, but where I'm from, up north in Indiana, you definitely need the radiant heaters in the shop. Alarm and safety panel. There again, that's part of the methane detection and part of the ventilation requirements that they have. You're going to have alarms that go off. It shows actually on the pictures there, you have 2 different lights that are going to flash and the actual detection panel that goes off. That's all part of the system that goes in. From a cost standpoint in that, it is going to involve some high investment dollars to be able to get in to do repairs. Keep in mind, if you're working on a system that the tanks are removed from the vehicle or they're vented totally all the way, now you don't necessarily need this stuff to be there. We'll be coming up to doing vehicle inspection and condition in the next segment. Okay, vehicle inspection for condition, suitability, and compliance. Now, this is pertaining mainly to aftermarket conversions. OEMs have already addressed a majority of these issues, so keep in mind what I'm talking about here is if you want to do a conversion on a vehicle. When we go to convert a vehicle, things that we have to keep in mind: engine condition. The engine has 100,000 miles on it and needs to have some rebuild done to it. You're going to have to do that before you do the conversions. You have the increased weight of the natural gas cylinders themselves. Depending on the type of cylinder that you use, you could be talking of adding as much as 1,000 pounds of weight to the vehicle just for storage of the CNG. Ride height specifications. There again, if I'm going to add that much weight to the vehicle, it's going to affect the ride height. Road clearance requirements. The specification for road clearance, if it's under 125-inch wheelbase, is supposed to be 7 inches with flat tires. So if you're going to store tanks underneath the vehicle, you're going to have to do some measurements to do that. If it's greater than 125-inch wheelbase, now it's 9 inches of clearance. So if you think about a passenger car, I don't know of too many cars that have like 9 inches of clearance if you're going to store it underneath, which means that, oh, you'll be putting it inside a passenger compartment area. So now we have to worry about venting the cylinder if there was something to go wrong that caused the pressures to raise up. So now we're going to have to worry about getting that to where it's not going to vent inside the vehicle. And then the other thing is range requirements. What about the range of the vehicle? What are you designing it to run on? I mean, if you're going to do total natural gas conversion with no gasoline at all, how much range do you need? So that's going to be a consideration of it. And then the other thing that goes along with the increased weight from the cylinders and that, of course, is suspension and handling. So there again, there's lots of things to consider when doing a conversion on a car, and just putting the system on is just one aspect of it. The other part is the additional weight and where am I going to put all this stuff that goes along with it. When we look at cylinders, we have different types of cylinders that you can see. So keep in mind that when we go and start putting the system on, cylinders that we put on are going to be an issue. And when we come to our next segment, we're going to talk about the actual different types of cylinders that there are and what the costs of those are. Now that we're getting ready to do the conversion types of cylinders, the first type of cylinder I'm going to talk about is a Type 1 cylinder. Type 1 cylinders are either made out of all steel or aluminum. And this vehicle right here has Type 1 cylinders in it. And as you can see, they are nice and yellow that show that, but they also look fairly large and bulky too. But they are the most inexpensive type of cylinder that there is out there. They are the heaviest though. So, if we go look at considerations on cylinder types, a Type 1 cylinder would be the cheapest way to get in, but at the same time, it's also going to be the heaviest and going to have me to make the most modifications to the vehicle. Now, a little bit lighter, a little bit different type of cylinder would be a Type 2. That's a metal liner with a hoop fiber composite. The biggest difference on that is I just got a little extra protection as far as using the fiber composite on the cylinder, and I can take a little bit of the metal away from the actual cylinder construction itself. That lightens up the weight some. So from a cost standpoint, we just about tripled the cost of our cylinder now. The next type of cylinder is a Type 3. Type 3, we have a metal liner that's completely wrapped or enclosed by a fiber composite. Now, there's two things that go with that. One of the things is when we fill a compressed natural gas cylinder, we get heat. The metal liner on the cylinder helps duct the heat away so you get a more complete fill. So on a Type 1, Type 2, and a Type 3 cylinder, that metal in the liner is going to act as a really good heat sink on it. On a Type 3 type cylinder, the thing about it is we've got the metal liner a little bit thinner, so now we're actually saving some weight in the vehicle, so it allows us to actually have better weight savings. The fiber composite that goes around there is going to give us a little bit more protection as far as durability. And then finally, the Type 4, we have a thermoplastic liner that's wrapped by a fiber composite. Now, this is the lightest, but it's also the most expensive. So now you have cost versus expense type thing coming into play. We have a total plastic liner, and then it's wrapped by a fiber composite. So basically, we went from a 1958 Cadillac to a Lotus that's made out of all carbon fiber as far as weight, if you want to talk performance of a cylinder and relate it to a car. But the thing to keep in mind is the Type 4 is the baddest as far as weight savings and everything. So I wouldn't have to worry too much about necessarily adding a whole lot of suspension modifications as far as springs and that to a vehicle for it. The next slide here shows the different types of cylinders as far as a cutaway. A Type 1 cylinder, the thing to keep in mind since it's all metal, with filling it and unfilling it, all the stress of the cylinder is going to be supported by the metal cylinder itself. In a Type 2, when we put the composite hoop around it, now that cylinder is taking 45% of it. The composite is 55% of the actual stress. In a Type 3, the metal liner takes 20% of the stress. The composite fiber takes 80% of the stress of filling and unfilling that goes with pressurizing and depressurizing the cylinder. The last on the Type 4, the composite wrap takes 100% of the stress that goes with pressurizing and depressurizing the cylinder. With that being said, that allows me to use the lightest weight. Okay, now cylinder valves. We have two different types of cylinder valves that we can come across. One of them is manually operated valves. I don't think I need to explain that too much. Obviously, you're going to have to go out and do it. The other is electrically operated valving. Electrically operated valves are normally closed. They're going to be energized or turned on either by the ECM or the ignition switch. So the thing to keep in mind is if I have an electrical valve, I still have to have a way of manually overriding it in case I have an electrical failure if I have to vent the tank. Now, the next slide I brought up is a tank valve wrench. Most manufacturers, unfortunately, use their own methods for being able to put a tank valve in, so you have to have their tank valve wrench to take and change their valves out. The thing to keep in mind about valves, if I have to change the tank for some reason, I'm going to change the valve out. I'm not going to get a new tank with the valve. So the tank valve wrench is going to be something that works really well if it was designed for that valve, so it actually takes it on and off without causing damage to the valve itself. The other thing is the pressure relief device. The pressure relief is what's going to actually come into play if I get too high of a pressure in the tank. Tanks are rated to a certain amount. If my tank pressure exceeds 5,000 psi, I'm going to vent that tank. That way I don't have to worry about the tank exploding. So I have a burst disc built into the valve assembly that allows the pressure to get vented out of the tank if the tank pressure gets too high.